Hey there, philosopher. Welcome to a deep dive. And this one, well, this one's crafted especially for you, for that mind that just loves to grapple with those big, fundamental questions, the nature of existence, knowledge, being, all that good stuff. And guess what? Today, we're taking our philosophical lens and we're focusing it on a field that tries to ground those very questions
Dick.
in our biology, in our past. It's called, you guessed it, evolutionary psychology.
Exactly. And for this exploration, we've got something really special. It's the entry on evolutionary psychology from the Stanford Encyclopedia of Philosophy. Think of it like our shared intellectual playground.
Yeah.
We're going to be digging deep, dissecting those core claims. We'll be looking at the debates it sparks, especially those that land right in your philosophical wheelhouse, philosophy of science, philosophy of mind. We're not just skimming the surface here. We're going for depth, real depth. And we want to see how all this impacts your philosophical toolkit.
Love it. So mission clear. Let's start with the basics. What exactly is evolutionary psychology? Like, what's the essence of it?
So at its heart, evolutionary psychology, and those are the capitals, it's a very specific research tradition. It wants to explain human behavior. But it does it by looking at these internal psychological mechanisms we all have. And the evolutionary bit, the crucial part, is that these mechanisms, they're not just random. They're adaptations. They're products of natural selection, shaped over generations. And they're there because they helped our ancestors solve problems, survive, reproduce, all that.
So it's not just like, oh yeah, biology influences behavior. It's a very particular way of thinking about that relationship.
Right, exactly. It's very specific. In fact, to avoid confusion, David Bowler, he suggested using capitals evolutionary psychology to set this tradition apart, to distinguish it from, broader biological approaches, ones that might not have that same laser focus on adapted psychological mechanisms.
Okay, I'm with you. So if evolutionary psychology is this distinct approach, what are some of those other broader biologically informed approaches? How do they differ?
Well, take human behavioral ecology, for instance. It's grounded in evolution, sure, but it focuses more on how the environment, our social context, directly shapes behavior. It doesn't always rely on those specific internal mechanisms as the main unit of analysis. They see adaptation a bit differently, too. More flexible, context-dependent, and potentially operating on shorter time scales than some evolutionary psychologists might suggest. Then there's developmental psychobiology. They're often, I'd say, more skeptical of the whole adaptationism idea. They emphasize the role of development, how we grow, the environment's impact on behavior. They might even say, hey, not every trait is necessarily a specific adaptation.
Wow, so we're talking about different levels of analysis, different timescales, even different starting points, fundamental assumptions about what evolution is actually shaping. But before we get too far, let's rewind a bit. Where did evolutionary psychology, as its own field, draw its inspiration from? Who are its intellectual ancestors, so to speak?
Oh, there's a rich history there. Sociobiology is a clear forerunner, especially the work of E.O. Wilson, applying evolutionary ideas to social behavior. But evolutionary psychology takes it a step further, by zeroing in on those psychological mechanisms as the targets of selection. Then we have ethology, with its focus on instincts, those fixed action patterns in animals. You can see evolutionary psychology's evolved mechanisms as like a more sophisticated cognitive version of those early ideas about innate behavior. And of course, we can't forget the cognitive revolution, the rise of cognitive psychology, cognitive science, that whole framework of seeing the mind as an information processor. Well, that's crucial for understanding those mechanisms in computational terms. Sometimes people call them Darwinian algorithms or computational modules. Computational meaning like the mind is a kind of information processing machine. Exactly. And this focus on computational models, it sets evolutionary psychology apart from fields like neuroscience or behavioral neuroendocrinology. They explore the biology of behavior too, but they don't necessarily frame it in those strict computational or information processing terms.
Now, I know as a philosopher, you're probably attuned to those grand theories, the ones that try to tie it all together. And I've read that evolutionary psychology sometimes presents itself with pretty big ambitions.
That's true, it does. Some proponents, they suggest that evolutionary psychology could be the foundation, a unifying framework for understanding, pretty much all of human behavior, like a bridge between the natural sciences and the social sciences. Pretty bold claim. But it's met with some, shall we say, healthy skepticism, particularly from social scientists. They see the value in different levels of analysis, right? Sociological, cultural, economic, and so on. And they're a bit wary of reducing all those complex social phenomena to just biology, to our evolutionary past. And of course, the whole issue of reductionism, that's a huge philosophical can of worms, as you know. Plus, there's the argument that evolutionary psychology doesn't even fully unify with those closely related biological approaches we talked about, like behavioral ecology. Their emphasis, their methods, they can be quite different.
So it's a specific approach, sure, maybe even an ambitious one, but it's got its own set of ideas. Let's get into the nitty-gritty. What are those fundamental theoretical tenets that define evolutionary psychology, the ones that make it tick?
Well, a very influential formulation comes from Lita Kosmides and John Tooby. They gave us 6 key tenets that really capture the essence of evolutionary psychology. The first one, they say the brain is a computer, but not just any computer, one designed by natural selection. Its main job, to extract information from the environment.
The brain as an evolved information processing machine, that's a pretty powerful starting point. What comes next?
So the second tenet, they argue that all human behavior, every bit of it, is generated by this evolved computer. It's a direct response to the information it processes. So to understand behavior, you got to understand the programs running the show, the cognitive programs, the underlying psychological mechanisms. The third tenet, these programs, they're adaptations. They're not just there by chance. They exist because they solve problems, real survival and reproduction problems back in those ancestral environments.
Okay, so we're not talking random byproducts of a big brain here. We're talking specific evolutionary histories tied to real challenges.
Exactly. And that leads us to the fourth tenet. It's a big one. These cognitive programs, so finely tuned for those past environments, well, they might not be so adaptive now. The world's changed,
Yeah.
and rapidly. But our psychology, well, it might not have kept up in every way.
That makes sense. The idea that we have these mismatches between, like, our ancient programming and the modern world, I can see how that plays out. What about tenet number 5?
Number 5. This one's a hot topic. It's the concept of massive modularity. We'll unpack it in more detail later. But in essence, it's the idea that the mind isn't some general-purpose problem solver. Instead, it's more like a collection of specialized programs, modules. Each one's designed to handle a specific type of information or solve a particular problem that would help our ancestors thrive.
So instead of a Swiss Army knife, it's more like a whole toolbox. Specialized tools for specialized jobs.
Precisely. And finally, tenet number 6. This one suggests that if we understand this evolved architecture, this collection of modules, then we can start to make sense of culture and society as a whole. It goes back to that ambition of evolutionary psychology to provide a truly comprehensive framework.
Right, the idea that even the complexities of social life, they can be traced back to these basic, evolved psychological building blocks. Okay, let's dig a little deeper into some of these tenets. You said it's the programs, the mechanisms that are the products of selection, not just the brain itself. What's the distinction there?
Think of it like this. The brain is the hardware, the physical stuff. But evolutionary psychology says natural selection didn't stop there. It shaped the software too. The specific programs running on that hardware. Those are the psychological mechanisms. And remember, a key point is that those programs were sculpted by pressures in past environments. So they might not always lead to helpful behavior in our current world, which is, let's face it, pretty different from the savannah.
Gotcha. And massive modularity, this idea of the mind as a toolbox, not a Swiss Army knife.
Oh, that's a perfect analogy. Evolutionary psychologists love to compare these psychological mechanisms to our organs, like the heart or the liver. Just like the heart evolved to pump blood and the liver to clean things up, each psychological mechanism is thought to have evolved to solve a specific problem, a recurring problem that our ancestors faced. Finding mates, avoiding predators, cooperating with others, you name it. They argue, just like you wouldn't expect one organ to do everything, you shouldn't expect the mind to be a jack of all trades. It's a collection of specialized tools, finely tuned for their particular jobs.
To bring this home for our philosopher friend listening in, can you give an example, like how do these core tenets play out in actual research?
Absolutely. Let's look at mate preferences, a classic example. Devendra Singh's work on the waist-to-hip ratio is perfect. The idea is that men have this specific psychological mechanism. It's sensitive to and prefers a certain waist-to-hip ratio in women, usually around 0.7. Why? Well, the evolutionary reasoning is that this ratio in ancestral environments, it correlated with fertility and health. So men with this preference, they'd be more likely to choose fertile mates, more kids, and voila, that preference gets passed down through the generations.
Ah, I see the connection to the tenets. A specific program to detect the ratio, leading to a behavior mate preference with an adaptive function way back when. Fertility signaling.
Exactly. And proponents of this idea would say this preference is probably universal across cultures, though how it's expressed might differ, and it's a product of those past pressures, not necessarily ongoing selection in the present. The research often involves standard psychological methods, visual stimuli, preference data, and they try to find that consistency across cultures.
And that cross-cultural consistency, that's taken as evidence for the universality and, by extension, the evolved nature of these mechanisms.
That's the typical interpretation within evolutionary psychology.
Yeah.
But you, as a philosopher of science, you'd probably pick up on this right away. That leap from universality to adaptation, it's a big one. And it's debatable. Yeah, widespread prevalence is suggestive, but it doesn't rule out other explanations. Convergent cultural evolution, maybe? Developmental factors leading to similar preferences across societies. The evolutionary part, those specific selection pressures, the adaptive advantage, that's often more inferred than directly tested.
This brings us right to that massive modularity idea, that fifth tenet. This seems to be a real centerpiece of evolutionary psychology and often a point of contention. So break it down for us. What exactly is the massive modularity thesis?
Okay, so the massive modularity thesis, it's a bold statement. It's about the very architecture of the human mind. It says our cognitive system is made up of loads and loads of innate, domain-specific computational modules. And crucially, these modules, they're adaptations. They evolve through natural selection to tackle particular challenges.
Domain-specific, meaning each module has its own specialty, right? It processes a certain type of information or solves a particular kind of problem.
You got it. Picture this. A dedicated module for recognizing faces. Another one for language. Maybe one for detecting cheaters. Those who violate social rules. We'll talk about that later when we get to moral psychology. This view, it's the opposite of the domain general mind idea. The idea that the mind is more flexible, that it has these general learning and reasoning abilities that can be applied to anything.
Now, this modularity thing, it's not entirely new, right? Didn't Jerry Fodor talk about this in his work on the modularity of mind? How does this massive modularity connect to or differ from Fodor's ideas?
That's a great point. Fodor did argue for modularity, but he focused on what he called input systems, things like perception, language understanding. He said these modules were domain-specific, fast, automatic, and they worked in isolation, meaning they didn't have access to information from other parts of the system. And he thought they had fixed neural architectures. But here's the key difference. Fodor argued that our central systems, the parts of the mind that handle higher-level thinking, beliefs, decision-making, those weren't modular. He thought they were too interconnected, too influenced by everything else in the system. This led him to be pretty pessimistic about ever having a full computational theory of how these central systems work.
So massive modularity goes further, much further. It says the entire mind, including those central systems that Fodor thought were domain general, well, they're all modular.
Exactly. It's a much stronger claim. Peter Carruthers is a big advocate for this. He argues that even our most flexible thinking abilities are built on a foundation of specialized modules. He knows about Fodor's arguments, but he tries to counter them, often using evidence and ideas from evolutionary psychology. It's important to remember, though, this is still a pretty theoretical debate. Philosophy of mind, cognitive science, they're wrestling with this, and both sides rely on thought experiments and logic as much as hard data. It's tough to prove or disprove these modules with experiments alone.
So we've got these two camps, one saying modules everywhere, the other saying not so fast. Okay, so what are the arguments for massive modularity? What makes people think this is the way our minds are structured?
Well, there are three main lines of argument. First, there's the biological argument. It's all about analogy. It looks at other complex systems in biology, the ones shaped by natural selection. The logic is that natural selection, it tends to build things in a modular way, step by step. Think about the organs in your body, each with its own job. So the mind, it's complex, it evolved. Why wouldn't it also be modular?
So it's the if nature does it this way, the mind probably works this way too argument. What's the second one?
The second is the computational argument. This one focuses on the nature of, well, computation itself. What kind of system is best for solving the huge range of problems that living things face? Supporters say a general-purpose system, it would be too slow, too clunky, less efficient than a set of specialists. The idea is different problems need different solutions, different ways of processing information, and specialized modules, they're the perfect solution.
And the third argument, the final piece of the puzzle.
Right. The third one builds on Chomsky's idea, the poverty of the stimulus argument. He used it to argue for innate language knowledge. But evolutionary psychologists, they've taken it further. They say, look, we do all these complex things. We have so much knowledge. There's no way we could learn it all from scratch from our environment alone. Not enough time, not enough information. So they say this points to innate modules, pre-programmed and ready to go. They give us a head start in those areas.
So it's like nature gives us some pre-installed software to help us navigate this crazy world, but I'm guessing these arguments, they haven't gone unchallenged. What are some of the pushbacks against massive modularity? What do the critics say?
Oh, there's been a lot of back and forth. For the computational argument, even Fodor, the modularity guy himself, he got his doubts. He said, hold on, is there really a clear way to define what cognitive success even means in a way that applies to everything? If not, maybe domain-specific systems aren't the only way to achieve it. Richard Samuels came up with an alternative model, the library model. He says we do have domain-specific knowledge, but our processing mechanisms, those can be more general purpose, like a librarian who can retrieve any book, even though the books themselves are specialized. And David Bullard, he directly challenged the idea that a general problem solver is inherently worse. He points to social learning, even the immune system, as examples of biological systems that are somewhat domain general, but still manage to do complex, specific things.
Those are some pretty good counterexamples. What about the poverty of the stimulus argument? What kind of pushback has it received?
Well, Fodor chimed in again here. He said, sure, the poverty of the stimulus might support the idea of some innate stuff in the mind. But does it have to be modular in that strong sense? Maybe there are innate general learning mechanisms or innate mechanisms that aren't so isolated. Kim Staroni, he's been a big voice against applying the poverty of the stimulus argument beyond language. He says, language, okay, maybe an innate module makes sense there, but for other complex stuff, behaviors, knowledge, he thinks our rich environment, our culture, those can explain it. We don't need tons of innate modules. He has this evolved apprentice model where we're basically wired to learn well from our surroundings and from each other. And Cecilia Hayes, she's offered non-modular accounts for things like folk psychology, our understanding of other people's minds. She suggests that this might come from general learning mechanisms, not a specialized theory of mind module.
So the critics aren't necessarily saying innateness is wrong. It's more about the extent to which our minds are really divided into these rigid, specialized modules.
Right. It's about degrees. And while this debate rages on, it's interesting to note that even some critics of the strong modularity view admit that thinking in terms of modules can be useful. It's a good way to conceptualize certain aspects of cognition.
This is shaping up to be a fascinating and complex debate right at the intersection of biology, psychology, and philosophy. Now let's shift gears a bit. We've talked about psychology and cognitive science, but what about the philosophers of biology? What's their take on evolutionary psychology?
Uh, well, it's fair to say that a good number of philosophers of biology have some, let's say, reservations about evolutionary psychology. Their criticisms often revolve around what they see as an overemphasis on adaptationism, this idea that most traits are the direct result of natural selection, shaped for a very specific function. They also worry about an overly simplistic view of evolution, potential reductionism, skepticism towards massive modularity, and sometimes a loose or imprecise use of the concept of fitness. But it's important to remember, as Bullard points out, most of these critics aren't against applying evolutionary theory to psychology. It's more about the how, the specific way evolutionary psychology goes about it.
So it's not a rejection of the whole idea. It's more like a methodological and conceptual disagreement about the best way to weave evolutionary thinking into the study of the mind.
It's about which parts of evolutionary theory are most relevant, how to form hypotheses about psychological traits, and what counts as good evidence. Evolutionary psychologists, they often start by looking at a trait and saying, hey, this looks well designed, it must have a purpose. Then they try to come up with a story about how that trait evolved, what pressures shaped it. And they test these ideas using methods from psychology. Philosophers of biology, they often push back on this focus on design as the main proof of adaptation. They bring up the classic concerns of Gould and Lewontin about just-so stories, plausible but maybe not well-supported evolutionary narratives. They stress that there are other evolutionary forces at play, not just selection for function, things like genetic drift, where genes change randomly over time, pleiotropy, where one gene affects multiple traits, and the possibility that some traits are just side effects of selection for other traits.
So it's a call for a more nuanced, more comprehensive view of evolution, not just focusing on adaptation driven by natural selection for a specific purpose.
Exactly. And philosophers of biology, they tend to have a wider definition of what counts as an adaptation. Evolutionary psychology often focuses on those fixed, universal, organ-like mechanisms. But philosophers, they might include things like phenotypic plasticity, which is the ability of an organism to change its traits based on the environment. And even behaviors themselves could be adaptations. This broader view allows for a much wider range of hypotheses about human behavior. It's not all about those specific modules.
And what about the methods used to test these evolutionary ideas in evolutionary psychology? You mentioned that as a point of critique as well.
Right. One big concern is the reliance on cross-cultural universality as proof of adaptation. If you find a trait across many cultures, it suggests something's going on. But critics say it doesn't really test the evolutionary hypothesis. It doesn't tell us how or why that trait evolved. Maybe there are shared environmental pressures or cultural transmission that lead to similar outcomes. It doesn't necessarily mean it's a specific adaptation. There's also the worry that evolutionary psychology doesn't always do enough to rule out other non-evolutionary explanations. Buller's example of mate preferences is good here. Do people prefer certain traits because they signal high status, which is something learned, or is it a specific evolved preference for certain cues that were linked to status in the past? It's tricky to tease those apart.
So, finding a trait everywhere doesn't automatically mean it's an adaptation with a deep evolutionary history. The bar for evidence needs to be higher, and it needs to directly address the evolutionary claims.
That's the gist of the philosophical critique. Now, some philosophers have defended evolutionary psychology against these criticisms, but the main view in philosophy of biology is one of, well, carefulness and critical thinking. They want to make sure the assumptions and methods are solid.
This is really key. It's not about rejecting evolutionary thinking in psychology altogether. It's about scrutinizing the specific approach and the evidence used in evolutionary psychology. Okay, let's see how this plays out in a very philosophical domain. Moral psychology.
Evolutionary psychology has definitely influenced some approaches in moral psychology, especially those that say we have innate moral capacities or intuitions. The idea, which often goes hand in hand with massive modularity, is that our moral judgments and behaviors might be, at least partly, the product of specialized modules. Modules shaped by evolution to deal with the challenges of social life.
So instead of morality being solely a product of culture or abstract reasoning, the idea is that it has roots in our biology and these cognitive mechanisms we inherited.
Right. A good example, as we mentioned before, is Cosmide's cheater detection module hypothesis. The idea is that humans have this specialized module that's really good at spotting violations of social contracts, people who cheat in cooperative situations. The evolutionary logic is that in the past, when cooperation was essential for survival, being able to spot and avoid those who took advantage without giving back, that would have been a huge advantage. And that pressure, over time, led to the evolution of this module.
A mental tool specifically for navigating the social world, for spotting those who might undermine cooperation, sounds plausible. But I imagine this hypothesis and applying modularity to morality in general, it's been debated.
Well, absolutely. Just like with other modularity claims, there's debate about whether a dedicated module is really needed to explain how we detect cheating. Maybe more general reasoning abilities, combined with learned social norms, could do the trick. Philosophers like Stephen Stitch and Sean Nichols have explored these alternatives. And from a broader philosophical standpoint, there are concerns about what it means for morality if it's grounded in these automatic modules. Does it undermine the role of conscious moral reasoning, of thinking about ethical principles? Does it challenge the idea of a universal ought, a moral standard that applies to everyone? Kim Sterlnay, as we discussed before, has suggested other evolutionary explanations for moral behavior that don't require a specific cheater detection module.
So while evolutionary psychology offers some really interesting ideas about how our moral sense might have evolved, the details, the implications, those are still being worked out. Philosophers are definitely engaged in that conversation. Now let's talk about another big philosophical concept that evolutionary psychology tries to shed light on: human nature. What does evolutionary psychology have to say about what it means to be human?
So evolutionary psychology has a somewhat different take on human nature compared to earlier evolutionary approaches like sociobiology. Sociobiology, like E.O. Wilson's work, it tended to focus on universal behaviors as the main expression of our evolved nature. Evolutionary psychologists like Tooby and Cosmines, they argue that human nature is more about the underlying psychology. It's about the collection of universal, complex psychological adaptations that produce those behaviors.
So instead of looking at what we do, it's about looking at the mental machinery that makes us do it.
Yeah, that's the shift. Tooby and Cosmides, they famously defined human nature as the evolved architecture of the human mind. Airy and Cummins have contributed to this discussion as well. Mashiri has a nomological account of human nature. It's similar, but a bit broader. He says it's the set of properties that humans tend to have because of our evolutionary history. And importantly, he doesn't limit it to just psychology. It can include other evolved and universal traits, like walking upright.
So a set of commonalities, some mental, some physical, that define what it means to be human from an evolutionary perspective. But I'm guessing this idea, especially the focus on universality, it's run into some philosophical roadblocks.
Oh, definitely. A lot of the criticisms mirror the broader concerns about evolutionary psychology we talked about, especially the ones about how we define adaptation and the whole issue of human variation. Critics, like David Buller, building on the work of Hull and Sober, they argue that focusing only on universal traits as human nature, while it doesn't capture the incredible diversity we see in our species. If human nature is just a fixed set of adaptations, how do we explain all the differences? The physical differences, the behavioral differences, the cultural differences.
It's like saying the common core misses the richness, the tapestry of human variation.
Right. And Inseman and others have pointed out the potential social and political dangers of these essentialist views of human nature, especially if they're used to justify existing inequalities. Barrett, he takes a different approach. Instead of focusing on universals, he described human nature as this wobbly cloud of traits. It includes all the variation. But some have criticized this view for being more descriptive than explanatory. It's like, okay,
Yeah.
we see the variation, but what does it mean? Where does it come from? The tension between these two views, the focus on universal adaptations versus the reality of human variation, it's a big one in philosophy.
So evolutionary psychology, with its focus on evolved mechanisms, it has implications that reach far beyond the ivory tower. It affects how we think about ourselves, about society.
For sure. And its ideas have been applied, sometimes with controversy, to all sorts of fields: literature, art, consumer behavior, law, even politics. The idea is that understanding those evolved predispositions can give us insights into all these areas.
But have these applications always been, let's say, philosophically sound? Have they been subject to critical examination?
Well, one philosophical concern is that sometimes people mix up the specific claims of evolutionary psychology with the broader, more established idea of evolution. This can lead to people treating specific and often debated ideas from evolutionary psychology as if they were undeniable scientific facts. For example, some work in consumer studies relies heavily on these hypothetical modules for adaptive thinking to explain why people buy things. But they don't always acknowledge the debates about modularity, the uncertainty about how these modules work. And sometimes, even more problematically, some applications have drawn on evolutionary ideas that are, well, discredited or very controversial, like the adaptationist theory of rape, which has been used in some legal and social contexts. That's a stark example of how things can go wrong when specific, contested evolutionary interpretations are presented as the absolute truth.
That underscores the need for careful philosophical analysis when we apply evolutionary ideas, especially those coming from a field as complex and debated as evolutionary psychology. What do you see as the most exciting areas for future philosophical work in this area? What are the big questions?
Oh, there are tons. We need a deeper, more nuanced philosophical look at the specific claims made in evolutionary moral psychology. We need to better integrate evolutionary psychology with research on emotions. And that whole concept of modularity at both the biological and psychological levels, that needs further exploration. It's crucial to keep the conversation going between evolutionary psychology and other biological approaches, as well as with the social sciences in general. We need to bring in insights from feminist perspectives, from critical theory, and the recent work that's been done compiling and reviewing research in evolutionary psychology that sparked new discussions, especially about human variation. We need to keep grappling with that. The tension between evolutionary psychology and other evolutionary frameworks, like cultural evolution, highlights the need for a more multi-layered approach to understanding human behavior and thought. And those contrasting views on the relationship between evolutionary psychology and other fields, from Dupree's worries about scientific imperialism to Buss's vision of a scientific revolution, they show that we need to keep thinking carefully about the scope and limitations of this approach. Philosophers of science also have a role to play here. They need to critically examine how evolutionary ideas, especially those from evolutionary psychology, are being used in other areas of philosophy.
So, evolutionary psychology, it's a powerful lens, no doubt, but it's a complex and contested field, especially when viewed through the lens of philosophy.
Absolutely. Evolutionary perspectives, they offer incredible insights into human nature. But evolutionary psychology, as a specific framework, as we've seen today, it's still being debated and scrutinized by philosophers.
And this brings us to a fundamental question for you, our philosopher listener. How should philosophy, with its emphasis on clear thinking, logic, and those big fundamental questions, how should it engage with these scientific accounts of human nature, like evolutionary psychology? How do we balance the excitement of new discoveries with critical thinking, with making sure the ideas are sound and the methods are rigorous? That's a question worth pondering. And for those who want to go deeper, we encourage you to check out the work of the thinkers we've mentioned today, explore those debates, see where your own philosophical journey takes you. Thanks for joining us on this deep dive.